Yeah, I know. So.
So I'm going to flip flop Thursday and Friday. So we're going to go ahead and just finish up our notes today, and then tomorrow, this differential equation practice day can just be part of our test review. So we can start going through our test review. Test review Friday, Monday, and Tuesday, a little bit of Wednesday, but we do need to start our next unit, and then our test will be next Thursday, week from now. And then I'll get back your quizzes tomorrow. Okay, if you can turn to page 23. So this is the last set of rules we have to know for this course. So this is inverse trig integrals. These are just going backwards from first semester's arc trig derivatives. But our inverse trig integrals is only going to involve sine, tangent, our arc sine, arc tangent, and arc secant. So imagine you're over here and we're having to take the antiderivative to get from the right side to the left. But with some slight adjustments here, we may not have a 1 involved. If we don't have a 1 involved, that's going to be our A value. So let me define a couple of things here. Your A is your constant. And then your U is your variable expression. So whatever has a variable in it is involved, whatever has the variable is going to be involved with your U. Whatever is your constant is your A. So I have a way of remembering, or yeah, so similar to arc sine, arc tangent, arc secant. You can see that arc secant is the only one with the absolute value, or with the absolute value on the right side. If there's no radical, then it's going to be involving with arc tangent, and then arc sine has a square root with the constant being first, followed by the variable. So one thing that allows us to see that there's going to be an inverse trig integral and not just like a regular U substitution is the relationship between numerator and denominator. So here's the big hint that allows us to know that it's probably going to be an arc trig integral, is you want to compare your degrees between numerator and denominator. And the thing that gives it away is that your denominator degree, don't worry about the square root, just look at the degree. Your denominator degree is going to be 2 or more than your numerator. So you see, yeah, so, oops. There's like a significant gap. So you see how this is x squared below, and this is degree 0. There's a gap of 2 or more. For number 2, you see how this is x squared below and a constant above. That's a gap of 2 or more. And here, degree 2, and then degree 0, that's also a gap of 2 or more. So that's the indication that extra gap is indicating that it'll probably be a good fit with our trig. So rather than, oh, this is the U value and I'm trying to, so that's the big distinction that you can tell by the beginning of the problem that it's going to be our trig. Okay, so now that we're convinced that this is going to be our trig, we are trying to get our A's and U's to show up for us. Okay, and you can tell that this one is going to fit a little better with arcsecant because the variable is the positive, and then the constant is has the negative, is following the negative sign. So once we can match up what we think is going to be a good fit, we want to get that denominator ready. So let me show you what I mean by that. Your denominator, you do want to set up your denominator like this. So we're trying to pull the A and U value, but the A and U value is going to be stored as part of a square, as part of an exponent. So start off by doing this. Create a set of parentheses with a squared outside, and sorry, let me zoom in a bit. Now we want to fill in these spaces with something that is equivalent to what we started with, but stored inside the parentheses. So what can I put inside the parentheses here? Just what? Just x, yeah. So x parentheses squared is the same thing as x squared. So we haven't done anything to change it, but it's just helpful to see, okay, whatever's inside here is going to be my u value. What can I put in here where if I square it, it's the same thing as a 9? 3. So there's your a. Okay, your u value has the variable in it, and your a value is the constant. So let's go through a little bit of u substitution. Actually, we don't really have to because u is equal to x, but I'm just going to do this. U equals x, du over dx equals 1, and then my a value is 3. I just want to make my problem look exactly like the rule so that I can be convinced that I'm ready to use my rule. Any coefficients I can push out in front, it's not going to impact my rule. Replace dx with du. My x is u, so that fits nicely. And then this is my u squared minus a squared. So I like to do this just so I can see, okay, I got a perfect match with the rule that I want to use. It's okay to have a coefficient in front, but after I get past that coefficient, everything matches perfectly. So now I'm going to jump into my rule. I'm going to start with that 5 first, because that 5 is going to have to stay with my answer. Times 1 over a. Now what's my a value? 3. So just replace the a with the numeric value of my problem, and then just follow the rule. Arcsecant absolute value of u, my u is x, over a, which is 3, and plus c. Okay, any questions with 1? All right, number 2. The giveaway here is this is going to be an arc trig because there's a degree 2 below and there's degree 0. There's a gap of 2 or more with a denominator holding the higher degree. So we're going to look at one of our arc trig options, and this is the only one without arctangent is the only one without the square roots. So we know we're targeting that arctangent. Now with arctangent, the a and u can be flip-flop. the constant can come first or the variable can come first. It doesn't really matter. I think the a and u is only going to matter in terms of the order for arcsine and arcsecant because one has to be positive and the other one has to be negative. So you know that your constant is going to be related to your a, and then whatever has a variable in it is going to be related to your b to your u. So let's start by setting up. Let's create a set of parentheses because we just want to make sure that we're pulling the correct a and u value by storing them inside a set of parentheses. Okay, what can I put in here so that if I square it, I get equivalent to 4? 2. And here, x minus 1 is already in that good good setup for us. So we can just copy that x minus 1 there. That's already set up for us. Okay, so let's find our a and u value. Again, your u value has the variable in it. And it looks like my derivative is not going to have any leftover coefficients, so there's nothing to keep track of. And then my a is just what's inside the parentheses. It's going to be 2. So the reason that we do this is so that you don't accidentally pick your a value to be 4. If you force yourself to rewrite it with a parentheses squared, then you're going to be less likely to make a mistake because you know that your a value is going to be the 2 and not the 4. Okay, let's set everything up. Make sure that if I were to replace everything, that it'll look exactly like this rule, and it should. Dx is replaced with du. My 2 is a. My u is x minus 1. So everything matches perfectly with the rule that I want to use. And now I can apply my rule. 1 over a. My a value is 2, so 1 over 2. Arctangent of u over a. My u is x minus 1. My a is 2. Plus c. Okay, number 3. Again, we know this is going to be a good fit for arc trig because, again, don't pay attention to the radical. Look at your degree there, x squared versus degree 0. That's a gap of 2 or more. We're looking for arc trig to help us with this. Okay, so let's set up our denominator, get our parentheses to show up, parentheses squared to show up. All right, what can I store in here so that if I squared it, I'm going to get a 7? So 7 squared would be 49. So what can I put in here? Root 7. Okay. I don't know if that's what you guys said in here, you guys. Yeah, so root 7, because let's double check it. Root 7 squared equals to 7. So that's going to be our a value. Okay, what can I put inside here so that if I squared it, I'm going to get 16x squared? What expression squared will give me 16x squared? What do you guys think? 4x. Okay, let's double check it. 4 squared is 16. X squared is x squared. So just double check, right? That whatever you put inside here, that after squaring it, you should be able to get to where you started with. Okay. And again, the benefit of doing this is so that we're not accidentally picking the incorrect a and u value. Now that we have them inside the parentheses, it's a lot more clear that my a value is the root 7, and then my u value is the 4x. Now, my u is more than just an x, so I'm going to have to worry about a little bit of leftover for my du dx. So derivative is 4, cross multiply. So dx equals du over 4. So there's going to be a leftover 1/4. That's going to be part of my setup. Okay, so this is a good fit for arcsine because it's going to be a squared minus u squared. So I should be able to get it to look like this here. Okay. I'll replace the square root of this with a squared. So square root of a squared minus u squared. My dx will get replaced with du over 4. I'm going to put that outside here so I can, doesn't look like a complex fraction. So this tells me that, okay, there's a leftover 4, 1/4 that has to be kept track of. So I'm going to pull that 1/4 out. But once I get past that 1/4, it should look exactly like the rule that I want to use. Okay, everybody good so far? So perfect match with my arcsine rule. So now I'm just going to jump into my arcsine rule. So 1/4, there is no 1 over a for arcsine. So I'm going to jump directly into my arcsine. Arcsine of u over a, and then my u value is 4x. My a value is √7, and then plus c. You don't have to rationalize the denominator. You can, but you won't get points taken off on the AP exam as well if you don't rationalize your denominator. It's okay to have a radical in the denominator. Okay, next page. So far in the first page, everything is kind of nicely set up in terms of, okay, I can quickly create my a squared. I can quickly create my u squared. And there's not a whole lot of work that needs to be done to pull the a and u value. We do have to create those parentheses. But this next page here, we have a trinomial. And a trinomial is not quite ready for us to jump into pulling the a and u value. So the way that we get ourselves ready is we go through an algebraic process called completing the square. So completing the square allows us to get our variable expression and our constant expression kind of separated or into a nicer so let's look at number 4 here. We have dx over x squared minus 6x plus 13. There's a gap. That gap of 2 or more is indicating to us that this is going to be a good fit for our trig. And also, we don't see any radicals, so we know that this is probably going to be a good fit with arctangent. So we're going to be working towards getting to that arctangent. But it's kind of hard to get a binomial squared with our u and our a values. So we're going to do a little bit of work to get that x squared minus 6x plus 13 ready. So we're going to step to the side and just work on this expression. So let's write this here. So x squared minus 6x, we're trying to get a constant that will allow this to factor nicely for us. So you're going to write it out this way. You're going to say x squared plus bx, in this case, minus 6x. And you're going to add a space because we're trying to find a constant that will allow this to factor, plus 13. But whatever number we create, we want to make sure that we don't change the overall value. So we're going to immediately subtract it right behind it. So if I'm going to do a plus 10, I want to do a minus 10. So I don't want to change the overall value. I just want to be able to arrange it in a way where I can factor. So what goes inside the space? What goes inside the space is this b over 2 squared. So b over 2 squared, my b value is going to be the coefficient in front of my x. So it's going to be the -6. So it's going to be -6 over 2 quantity squared. The quantity squared is always going to make whatever you you started with turn positive. So these will always, well, this will be the positive number. This will always be a negative number. So -3 squared is 9. So we're going to put a 9 in the first space. And then a 9 in the second space. So this should factor nicely for us. What multiplies to be 9 and adds it to be -6. Yeah, -3, -3. So you do x minus 3, x minus 3. And what I mean by factor nicely is that this will always be the same, which we can merge into a binomial square. And then 13 minus 9 gives us 4. And now we have a problem that feels more like a starting point from the first page, where everything's already nicely set up. We can pick out our a value and our u value and our a value a lot cleaner. So now let me reset and rewrite my problem with my parentheses squared ready to go. So the x minus 3 squared is set up perfectly for our u value. We can just go ahead and carry that down. But the 4 will be adjusted slightly. We'll put a what inside here? 2. Okay, go through your u substitution, but we're not going to have any leftover from our u value. Right, let's go ahead and replace everything. Dx becomes du. My u squared plus a squared is ready to go. This fits perfectly with my arctangent rule. I can now jump into my arctangent rule on the right side. So 1 over a, so 1 over 2. No leftover coefficient that we have to keep track of besides the 1 over a. Arctangent of u over a, and then plus c. Right, questions? Example 5 is a little bit more complicated than I want us to be able to do. So let me change to a different problem. So the first thing I realize is there's a gap of 2 or more, right? Degree 4 versus degree 1. We want to be able to rely on our trig. There's no radical below, so our tangent will be a better fit. And it's a trinomial, meaning that we have to go through completing the square so we can get a nice u and a value to show up for us. So we have to go through complete the square with the denominator. So we'll say x to the 4th plus 2x squared plus space, and then plus 2 minus space. So we're always going to do a plus space and minus space on either side of your constant. All right, b over 2 squared is the formula that tells us how to fill in that space. My b value is what? 2. Yeah, your b is whatever in front of your It's always your A and your B and your C. So this is 2 over 2, which is 1. 1 squared is 1. So we'll fill both sides with 1. Now we can still factor with this. This is x to the fourth, x squared. It's just that now x fourth is now broken down to x squared and x squared. But if we fold this out, it'll get us something in terms of x squared. So multiplies to be 1 and adds up to be 2. What number can we put there? What about 1 and 1, right? 1 times 1 is 1. 1 plus 1 is 2. If I fold this out, I should be able to get to where I started. X to the fourth plus x squared plus x squared. That's plus 2x squared plus 1. So you're always going to be, the whole point of completing the square is you're going to get 2 duplicates that you can merge into a binomial squared. And the 2 minus 1 just becomes 1. Okay, so now let's reset. X over parentheses squared plus parentheses squared. My u value is, again, it doesn't matter which order you put them in. Just know that your u value has a variable in it and your a value is the constant. Okay. 1 is not going to change, right? 1 I can still store as 1 squared. Okay, we'll go through u substitution. Now this is going to have a leftover x, but it's okay because there's an x waiting for us. So the derivative should pair up and cancel out nicely for us. So, okay, our u value is x squared plus 1. du dx. Cross multiply. And your a value is 1. Okay, let's make our substitution, see if we can get it to look exactly like the rule that we want to use. I'm going to keep the x there for now because the x should cancel out later. We have u squared plus a squared. Dx becomes du over 2x. X just goes away. That's a good sign. Pull the 1/2 out in front. Now, after we get past that 1/2, it should look exactly like the rule that we see for arctangent. So now we just follow the rule that we see at the top of the page. We'll keep the 1/2 first, and then we'll do the 1 over a, arctangent of u over a plus c. I don't have to keep all these ones if I don't want to. You can leave it in that form, or you can clean it up a little bit. Okay, any questions? Okay, with the remaining time that we have, I'd like for us to do more practice with solving differential equations. So let's see if we can pick out another one from your packet, from this packet here. Page 19. Start your initial steps, cross multiply first, and then decide if anything else needs to be moved. Now we'll do this with you in a second. So once you cross multiply, our variables are already nicely separated. Our dy dx's are in the right places. Our y's and x's don't have to be moved. So we're ready to go. I like to leave the left side as bare, as minimal as possible. If there was a -2 or 3 in front, I would have moved it over to the other side and made it shift over. Okay, but both sides is just power rule. As soon as I take my antiderivative, I'm looking to see, is there something easy that I can clean up on the left side? So the easy thing for me to do is to just multiply by 3. The -2 and 2 cancels out. I can distribute that 3 through. And when I get to a point where my equation looks relatively simple without the radical getting in the way, I like to solve for C when my equation is looking at its most cleanest. So I'm going to go ahead and just get my C taken care of. Again, it doesn't matter where you solve for C, and because it doesn't matter, I like to kind of choose my spot to do it so that there's least algebraic steps for me to have to wade through here. That's just my preference. Okay, so 3n for y, -1n for x. So my C is equal to 30. Once you solve for C, go back to where you started making that substitution and update that equation at that stage. And then we're one step away to getting y by itself. We can take the cube root of both sides. That should lead us to our answer. Okay, let's try number 2. I want to cross multiply with number 2, but I see that y prime. I want to get that y prime to be showing me something more descriptive. So I'm going to say dy over dx, but I'm going to have that dx share the same space as my 3 minus x. So I'm just converting that y prime to be dy over dx. I don't want to do a complex fraction, so I'm just putting that dx and sharing the same space as the 3 minus x. And I'm also protecting that 3 minus x with a set of parentheses just to know that this stays together. Okay, cross multiply. I like to cross multiply in a way where my dy will end up on the left and my dx will end up on the right. And yeah, don't feel like you're doing something wrong when after you cross multiply, your x's and y's are out of place, right? It's okay as long as your dy and dx's are lined up. But when you cross multiply, the whole purpose is that you get everything out of the denominator, and then I think it's easier to move things around once everything is up in the numerator. Okay. Are we okay with getting to this step here? So when you cross multiply, you can get some things out of the way. The dy and dx's are going to be lined up nicely. They're both in the numerator, dy on the left, dx on the right. And now we can ask ourselves, what is out of place? If you see anything out of place, we want the x's gathered together on the right. We want the y's gathered together on the left. What do you see is out of place? Well, what needs to move? What do you see? Or is this ready to go? Are the variables separated? Any thoughts? You're close. We don't have to move the 6 along with it. It looks like it needs to stay together. They're only next to each other. It's only the 3 minus x that has to be if we want to move the 3 minus x, that's to go together. But we can move the y without having to move the 6. So I would say just move the y. If you move the 6 over, you got to move the 6 right back. So yeah, so I think that's a good point because it looks like the y and 6 have to go together. The only time they have to go together if it was 6 plus y. If it was 6 plus y, then yes, we have to move the 6 along with the y. But if things are being multiplied, we can take one away from the other without causing an issue. So, and where does the y go? Good, in the denominator. And it's okay to have your variable in the denominator. Don't feel like something is wrong when the variable's in the denominator. We have a rule that can handle that denominator location. Okay, so now the variables are nicely separated, right? Your y's are together, your x's are together. Antiderivative. Okay, let's finish this problem tomorrow. Your homework is page 13 and 14. If you guys can turn to those pages right now in your packets, this is dealing with the arc trig integrals. But number 35 is more complicated than I want, so I changed the problem. If you look at 35 and just change that 2x to just 2. So just cross out the x and just go from 2x to 2. It was on page 14, I think, number 35. I'll send out a reminder this afternoon, and then the link for the solution is on my website. You can check the key there as well. Okay, come get your phones. Tomorrow we'll start our test review.